You clicked because you are building AI agents and they are behaving like black boxes. You are watching them hallucinate, loop endlessly, or make decisions you cannot explain. The real stakes are not about making these agents more autonomous, but about making them auditable enough to trust in production. Today you will discover why deterministic traceability is the harder engineering constraint and how specific hardware features are turning debugging into a core reliability feature rather than a performance drag. The industry is currently obsessed with pushing agents to act more independently. We see headlines about agents that can plan, execute, and self-correct without human intervention. The assumption is that more autonomy equals better performance. But this intuition is fundamentally flawed when you move from prototypes to regulated environments. Research across workforce, security, and compliance domains consistently shows that as an agent's autonomy increases, the ability to attribute responsibility and reverse errors diminishes. This creates a dangerous trade-off where the very feature that makes an agent powerful also makes it impossible to govern. Consider the findings from a comprehensive survey of 1,500 experts and workers regarding the future of work. The data reveals a clear preference for transparency and augmentation over unchecked automation. People do not want to hand over total control because they fear job displacement and over-reliance. They want systems that can be audited. This preference is not just a cultural sentiment, it is a regulatory requirement. Studies on architectural tactics for regulated contexts demonstrate that increasing an agent's independence necessitates a proportional reduction in its scope of action to maintain reliability. You cannot simply scale autonomy without a corresponding investment in traceability. The problem becomes acute when we look at cybersecurity. Current prompt-level safety controls are fundamentally insufficient for deployed agents. Autonomous decision-making allows the system to bypass static guardrails that were designed for static inputs. This creates vulnerabilities like agent collusion and memory poisoning. Features that enable autonomy, such as persistent state and self-directed loops, amplify adversarial capabilities just as much as they aid defense. The dual-use nature of agentic AI means that unchecked autonomy can automate reconnaissance and evasion with terrifying efficiency. Without robust audit trails, there is no governance mechanism to prevent catastrophic failure modes. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. This is why the engineering bottleneck is shifting. For years, the challenge was inference latency. Could the model think fast enough? Now, the challenge is the overhead of logging. Implementing high-fidelity logging often introduces latency that can stall real-time decision loops. If you are building an agent for high-frequency trading or autonomous robotics, even a millisecond of delay caused by writing logs can negate the benefits of autonomy. You face a critical trade-off. Do you prioritize speed and lose visibility? Or do you prioritize visibility and lose speed? Here is the thing that changes the equation. The solution does not lie in writing less code or accepting lower fidelity logs. It lies in the hardware that runs the inference. We are seeing a shift where high bandwidth memory and low latency inference capabilities allow for real-time, non-blocking audit trails. These hardware features enable the system to record every decision, every token generated, and every action taken without stalling the execution loop. The logging happens in parallel with the thinking, not sequentially after the fact. This transforms the nature of debugging entirely. Instead of a performance drag that slows down your application, the audit trail becomes a core reliability feature. You get the full history of the agent's reasoning process instantly. You can reconstruct the exact sequence of events that led to an error. You can see how the agent weighed different options and why it chose a specific path. This level of deterministic traceability is what production-grade systems require. It allows you to satisfy mandates like the European Union AI Act and GDPR without sacrificing the speed your business needs. The research supports this architectural shift. It shows that current assurance mechanisms are insufficient without specialized security frameworks that leverage these hardware capabilities. We need architectural patterns like execution sandboxing and zero-trust identity that generate immutable logs of every action taken. These logs must be high fidelity to be useful. If you only log the final output, you have lost the context of the decision. If you log every intermediate thought, you have a complete picture. The hardware advancements make this granularity feasible in real-time scenarios where it was previously impossible. Think about the implications for a workforce integrating these tools. Without a systematic framework to trace agent decisions against human agency goals, workforce integration fails. You get over-reliance and a lack of corrective intervention mechanisms. When an agent makes a mistake, you need to know exactly where the logic diverged from the intended path. You need to know if it was a data issue, a model hallucination, or a logic error in the planning phase. High bandwidth memory allows the system to store these massive amounts of context without slowing down the inference engine. Low-latency inference ensures that the logging process does not become a bottleneck. This is the insight that separates production-grade systems from experimental prototypes. Most teams are still trying to solve the problem with software optimizations alone. They are trying to compress logs or write them asynchronously in ways that introduce gaps. But the hardware is now ready to support a different approach. We can build systems where the cost of observability is negligible because the memory bandwidth and processing power are dedicated to keeping the agent moving while the audit trail is written in real time. The result is a system that is both fast and transparent. You get the autonomy you need to automate complex tasks, but you also get the auditability required to trust those tasks in a production environment. This is the future of agentic AI. It is not about building agents that think for themselves without oversight. It is about building agents that think for themselves with a complete, immutable record of their thoughts. This allows us to scale autonomy safely. It allows us to integrate AI into critical workflows without fear of the black box problem. The path forward requires us to stop viewing logging as an afterthought. It must be a first-class citizen in your architecture. You need to design your agents with the assumption that every single action will be recorded and analyzed. You need to leverage the hardware capabilities that make this possible. High bandwidth memory and low latency inference are not just performance upgrades. They are the enablers of trust. They turn the debugging process into a feature that actively improves system reliability. As you move forward with your own projects, remember that raw autonomy is not the ultimate goal. The ultimate goal is reliable, auditable automation. The research is clear. The workforce prefers it. The regulators demand it. And now, the hardware makes it possible. By focusing on deterministic traceability, you build systems that can scale without breaking. You build systems that humans can work alongside, not just systems that work for themselves. This is the engineering challenge that defines the next generation of AI agents. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.